Hello, let's now take a look at our image signal processing tuning tool for STM32 developers. Our demo setup includes one lighting box, one color palette, our STM32N6 development kit, and a camera module included in the kit. You can find all the digital tools, software and documentation on our ST webpage, where you can download the software application for your operating system, Windows, Linux or Mac. You can also download the Cube ISP package, where you can find the binary files that you need to flash into your STM32N6 microcontroller. This is the first window that you will see when you start the software. Here you can see all the available devices through the COM ports, and in this case our N6 port is on port COM6. We connect to our board, and then you will see a default configuration that is available for our camera models. In case you are using a different camera sensor, you will need to start tuning from scratch. The first step is to configure the statistics removal module. This module removes potential statistical data inserted by a sensor, and it is typically used by sensors with a parallel interface. But in this case, since we are using a CSA2 sensor, we don't need to implement this module, so we can keep it disabled. In the second step, you can configure the bad pixels, and since we are seeing in our picture that we don't have any pixel defects and the quality of our camera sensor is quite good, we can also keep disabled this module. For the third step, we can configure the black level, which suppresses a potential positive black level offset that occurs when the sensor sends no new pixels while capturing a black picture. For this step, we will need to cover our camera. Then in our tool under the pixel luminance window, we can calculate the average RGB value and luminance before Demosaicing. As a result, we can see the offset level for each RGB component. We take these values, update them in the profile and apply them to the sensor. For the next step, we can configure the Demosaicing. The Demosaicing converts the raw image captured by the sensor into a full color image. For instance, converting raw by 8 bits per pixel image to an RGB 24 bits per pixel image. The underlying heuristic filters try to extract and adapt to edges, horizontal and vertical lines, and lone pixels. The next step is to configure the gamma correction. This module implements gamma compression on each RGB component to store gamma compressed pictures as defined in the sRGB standard. To achieve good color rendering while damping the buffer, it is important to enable gamma compression on both pipelines. So we enable both, the first pipeline for the LCD display and the second one for the ISP configuration. Next step is to configure the exposure control. This module aims to configure the sensor exposure to ensure the frame is well exposed, so it is neither too dark nor too bright. The exposure is not controlled by a parameter inside the ISP, but by the sensor itself, by updating the exposure time or the sensor gain. In this case, we are using the embedded auto exposure control algorithm, which adapts the sensor gain and exposure values during the auto white balance profile calibration. You can select the different exposure compensation for better results according to your preference. The next step is to configure auto white balance profiles. This module interacts with the ISP gains and the color correction matrix block. It applies independent gains to each RGB component to ensure white appears white. Here you can add a new profile with the default values and apply it to the sensor. Then you will need to download the sensor raw data, go to our analysis tool, select the white balance gain, and upload the raw data that we have just downloaded. Then we run the analysis tool and select the resulting values provided by the tool to update the profile and apply them to the sensor. Here you can have different profiles, for instance, when you have different color temperatures. Additionally, you have to configure the color correction matrix for optimal color renderings. Here you need to download the ISP configuration, go again to the analysis tool, select the color correction matrix, upload the ISP configuration and start the analysis. Then you can copy the color correction matrix results, update the profile and apply it to the sensor. Next, we have to configure the contrast. This module concludes the image processing pipeline. It assists to tune the brightness of the pixels by enhancing the contrast of the frame by nonlinear emphasis of pixel luminance. For this demo, we will leave the default values as the results are already satisfactory. For the final result, we can download the ISP configuration again, then go again to the image analyzer, select the advanced image and upload the final ISP configuration. The results show the difference between the reference color and the real color obtained by the camera and ISP block. Here you can fine-tune the different modules that we just showed according to your preference. You can also export the configuration as a header file or as a JSON file to use it later in your application on our STM32N6 microcontroller. For a more detailed description of this software tool and all the different modules, you can refer to the documentation or our wiki page on STMicroelectronics website. Thank you for watching.
We also provide the links in the slides. So we provide two links, one for the wiki that's well described, and also we provide the link where you can download the tool and the binary needed to flash on the N6 board. And now we'll introduce the video encoding capabilities of the N6.